minimize this. Okay, so I hope everyone had a good break. I did. It was nice. I actually took a little bit too good of a break. I forgot about all the work I had to do until like Friday to get ready for these next 2 weeks. So um, anyway, I'm ready to get back into it now. Um, okay, I guess my S should not be capitalized there. Okay, so now I think we're ready. I want to see if there's a new compiler version. I like to check here whenever it's new. No, so there's no. See, there's a bunch of 4.25s here, but there's no. If I scroll down a bit, what I look for is this. Whoops, this one right here. I don't want the nightly because that's not the stable version. So I'll stick to 0.4.24, and I don't need to select it here because I specified here, but I do like to check. Okay, so what are we doing today? Today, we're actually going to be doing a pretty simple contract. It's really just going to be, it's going to allow anyone, any Ethereum identity to punch a clock. So, I mean, if anyone's worked in any kind of big business, you typically have like a time clock or a time punch. I don't know what they're called usually, but some machine you go to and you say, okay, I'm here. You log in for the day and you log out, and that's how they figure your hours. We're going to do the same thing in a smart contract. So this will just be one contract, which is a little bit of a departure from how we usually do things. Typically, we've been allowing the user to create their own contract of a certain type. That's how we did the wallets and the billable wallets and all that. This time there isn't going to be a factory contract, and there's only going to be one contract we're working with, and that is the time, this punch clock sort of device, or this punch clock contract. And so there'll only be one, and you could just imagine, of course, it's on Ethereum, so it's everywhere in the world at the same time. We don't really need more than one. And it's just going to allow the user to say, okay, I'm clocking in, I'm clocking out, whatever. And then it's up to the interface, which we'll get to later. We might even start on that today, but the interface will be responsible for actually filtering through those and like tallying things and making sense of the data. But the very first step here is to just make the actual logging contract, which, as you'll see, is going to be extremely simple. So let's just dive right into it. I'm going to call this a punch clock for right now. We might change that later, but that's what it'll be for now. And this thing is really just going to have two parts to it. It's just going to have an event definition and then a function that a user can call to trigger that event. And that's really it. So, I mean, we might actually get done writing this contract in like 10 minutes here. So the event that I sort of came up with here is we're going to have a, what did I call it? I think I have some notes here. Didn't actually write any of this code yet, but I did sort of, I guess I didn't name the event. Okay, so let's see, the event, I guess we could just call it punch for now. And then we need the address, so who it's from, so who's doing the, I'm going to say agent actually. I like the term agent when I'm referring to any possible Ethereum address, because if I could put user there, but this could also be a script that's punching in and out. So agent, I find, is more agnostic to who's actually doing it. And an agent could also represent a contract, which so right now we're on week 4. On week 5, we'll be working on some composite identities, and those contracts might then interact with this punch clock, and that would also be an agent. So anyway, we have the agent. What else do we need? I think just a string of what their message is, or what their data is. I'm going to say action. We might the name there of that variable we might change, maybe even several times. But and I'll get to what that is going to be here in just a second. So now that's all that we need for the event. Now let's do a function. And what are we going to do this? I mean, I guess I could just name it punch clock, or punch the clock, or I don't want to have an event and the function named the same. I guess I like the function named punch, and I'll make this a punch event for now. Okay, so when a user punches it, we don't need to take an argument of who it is, because we'll be able to get that within the function from our message.from. We do want to take what they want to, what their action is going to be. And then we just emit the event. This is super simple. Punch event. Oh, and I do actually want to capitalize this. I tend to capitalize events. Again, there's no experts, in contract development. If anyone tells you they're an expert, they're lying, or they're just delusional. I mean, I would say there's almost experts. I would say I'm an almost expert, and there's some other almost experts out there, but we're all figuring this out. So conventions such as capitalizing event names, I mean, it just seems right to me. And if anyone else tells you that there's a real hard answer that's industry accepted, then that's a bunch of bullshit. So feel free to experiment with all that stuff. I certainly am. Okay, so our event needs the address of the agent, and that's just message.sender. It needs an action, which we can pass forward from the argument, and that's actually it. So this is ridiculously simple, and it's almost so simple. Some of you might be wondering, like, what is the point of this even? The point is, so I guess I'm going to start compiling this as I'm talking here. Oh, I guess I need to put a visibility on here. So this punch is external, so anyone can do this. Smart contracts are nice because they're sort of automatically, I mean, I do a lot of game engines, so I want to call it, they're automatically multiplayer. As soon as you deploy a contract, if you can compile it and deploy it, and if you don't put any restrictions on the logic here, anybody can access it, and furthermore, several people can access it at once. And so that automatically sort of, that automatic multiplayer or networked sort of functionality, we're going to use that. We're going to exploit that by just having an event emitter, and then we're going to have a bunch of interfaces point at this contract, which will be deployed shortly on an address. And then users can punch into it, and then other users can just watch it and watch for the punches, and then use that data. And if you think about it, that's what a punch clock at a place of business, a brick and mortar place of business, is doing. It's just logging the actions for some other system to actually go through it and calculate some sort of payment from that. So I guess I'm not even. Usually I go to JavaScript VM and test this, but there's really no logic here to test. I mean, I guess I could do it really quick because it's just so quick. So deploy. Here's our deployed punch clock, and I could punch with an action. And so the action that you might put in here is, let's see, shift start. Maybe it's something like that. Okay. Punch. Okay, there we go. We see there's one log here. I can click, scroll down a little bit, and look at the log. And here it is. The event is punch event. And we got the from, and we got the, wait a minute. Let's see here. Agent and action. So it looks like our events, when they're outputted with Remix, I don't want to spend too much time here. It looks like it's giving us them twice. One first as numbered arguments, and then secondly as named arguments. You can see that they're copied over, so that's interesting. And it says the length is still 2, so that's odd. But anyway, we can see that works. Okay, that's good enough for now. Let's go to injected in Web3. Now I'm going to change to Ropsten as well. And I'll probably refresh the page here. Yep. I'm so rich on Ropsten, guys. Look at that. Okay. I guess it has to compile again, which is a little silly, but okay. And then run, injected, deploy. Okay, MetaMask comes up, and now as soon as we get an address from this, we're actually going to load it in in Pragma. So once again, we're going to go to with Pragma. I wish that the contract deployment was working. It probably works on Windows PCs. It worked on my Windows PC, so I would recommend you check it out. It's just a more polished version of Remix. But one thing I can still use it for, even on Linux, is I can actually just manually add the contract, which we will do once we get the address. And I think this week's project in particular will really highlight how useful this Pragma platform is, especially when we can start sharing interfaces. Anyway, so it looks like our transaction, our contract creation is, there we go, it's success. So we can click on here to get to the contract. And there's our contract address. Now to add it to Pragma, again, if you ever are, the two pieces of info you need when you're going to, when you want to put an existing contract into some other system is the address and the ABI. And Pragma is asking us, we can name our contract, but that could be anything we want. But whenever you want to give access to your contract to some other interface or system, you'll need the ABI and the address. So, and once again here, to get the ABI, we go here and copy it from here. Go back to Pragma, paste that in, and then we're going to name it, of course, punch clock. Okay, submit. Now we got a punch clock factory here, and I'm going to go here and go to interact. Now this will, whoops, I didn't mean to do that. Get out of there. Interact. Now, so now we're going to be using these two tabs here, interact and logging. These are where I think this interface, this Pragma tool really shines, because the first thing right off is that I can click on this and make it shareable. And now I'm going to copy this and put it in the stream chat. And Seiron said that he would be ready with MetaMask and some Ropsten Ether. So now he'll be able to actually go to the link I just posted, which is different than the link up here. This confused me actually at first. If I can copy this link, and you'll see as I paste it in here, it's actually a different link. They go to the same contract. Yeah, I think the difference is that the one I was just on is more like it knows I'm the developer, so it gives me some extra stuff, like I can make it shareable or not, for example. I hope that didn't change the link. I'm gonna go and paste it again just to see. Okay, same link. Anyway, okay. So so I guess I'm just gonna do a punch, and Seiron, why don't you do a punch as well? And you can put it whenever you want here. I wonder, I don't think I need quotes. So let's just say punching in and submit. And Seiron, just do the same thing, put whatever you want, and yeah, we'll watch this. And now when this goes, then we'll be able to look at the logging and actually see the event get logged. Now, this is kind of interesting. While we're waiting on this, I'm going to make an interesting point about Ropsten. So Ropsten is a testnet, which means that in theory, all these tokens that I have are worthless. However, what's interesting is that it's still being mined on, and I believe that the people doing the mining on Ropsten, I mean, the blockchain is working. I mean, we'll see this get mined, and that means that there's people working on the blockchain, but they have no incentive to do so. So, because the tokens that they're mining are meaningless. So, I suspect what's happening is that people are there's maybe a couple networks that are up, people just doing it out of their own goodwill, because they know people would like to develop on Ropsten, well, on Ethereum in general, without having to worry about getting Ether. But what's interesting is that with this one, our contract doesn't handle money. It's actually just record keeping. So we could actually keep our contract on Ropsten and use it. I mean, practically speaking, we could use it for a production run, or a production stuff, because it still reliably processes the transactions. Now, that's interesting because we're getting, utility out of this thing that actually is being mined with sort of like fake Ether. So I suspect that eventually this will break down as this gets more popular and people start realizing they can use Ropsten and other testnets for sort of like record keeping for free. essentially for free. I bet that that'll sort of break down. Maybe, I've gotten my testnet Ropsten from a faucet. Maybe the faucets will be harder to find. I don't know how that's going to work out, but kind of an interesting note is that we can use Ropsten as a real Ethereum network, given that as long as our application doesn't need to use real Ether, the real value. Okay, so we've just gotten mined. I also got a message from Seyron here. MetaMask didn't open on Pragma. That's interesting. Can it open on other sites? Can you get it to open in general? Seyron? Okay, so while I'm waiting on that answer, there's a lag on the stream. We can see the event log here. First of course, this is all, it doesn't know how to format it because Etherscan doesn't have our ABI. However, Pragma does. If we go now to logging, it'll load here for a second, and it should. So there we go. There's my punch event. So you can already see that in a very small, minor way, my extremely simple punch clock contract is already being useful. I mean, this punch event, and actually, Seyron, why don't you, if you can go to that page and go to the logging, see if you can see my event. Even if MetaMask doesn't work, that'll be interesting to see. But so I don't know if it'll work without MetaMask, but certainly if the MetaMask is working, then anybody will be able to go to this page and see this clocking action. And again, this is, it's on Ethereum, so it's unhackable, it's signed, and the agent here, we know for sure that is the person who did it. So we have this built-in authentication, which is really nice. We also have actually, so I could have put in this event a time. However, this event has a block number, so the interface could pull that block number and get a time from it. It's a little awkward for the interface, but that's more because Web3 is a little still new and undeveloped. That block number is in there to get. So any interface can look at this and say, okay, get me all the punch events with a certain agent that was after a certain block number, for example, and pull it sort of like a database. But again, at a database, you'd have to have it on a server, someone paying the server bill. And right now, even if this is on mainnet, there would be no server bill. There would just be gas fees, which is, I think, a more elegant solution to certain problems. No login. Oh, so no event login without login. Okay. Yeah, so Seyron, I would say go ahead and see if MetaMask can open at all. See if you can get it to unlock and open in any web page. If anyone else is watching and they would like to help out, well, I guess we only have one viewer. It's just me and you, Seyron. All right. So let's see. I could log into another account and log an event, but that won't really show us much. Let's see. So what's next now? Well, I mean, that's pretty much item 1 already done. And it is indeed just a glorified event emitter. So cross that off. Seyron, yeah, if you could, I guess the next thing for you is just to see if you can get MetaMask working. And for us, so one thing I want to do is I want to change this contract a little bit. I want to add this indexed keyword indexed. Where do I put that? Solidity event index. Oh, it's right. It's in between. Okay. Address indexed. And indexed action as well. So indexed is sort of like similar to if anyone's done database work. When you make something indexed, it's easier to search for. And of course, depending on the node you're connecting to, nodes can keep or drop logs. So that's something we'll run into later is if you have a contract that emits events and you're connected to a node that doesn't retain all events, then you might not be able to get events in the past. So you kind of have to be careful about who you connect to and how you get your events. And that's just another aspect of the big hairy ball that is Web3 and events. And that's why if you go to Toasty Coin, you load any given burnable payment, the the history of the burnable payment takes like up to 2 minutes to load. I mean, it's kind of crazy. Anyway, so I've made that change. I don't need to redeploy. I'm not too worried about it now, but that is a good thing to have there. Now, I guess the next item on our list here, on our outline, is to, well, we've already deployed on Ropsten. I guess we've already tried this, although we're still waiting on, hopefully Seiron can start interacting with it. You can send and receive testnet ether on faucet. Okay, with MetaMask, I guess. But MetaMask doesn't open on Pragma. That's interesting. What system OS browser are you using? I'm just typing it so other people can follow along if they look at the stream chat later. Okay, while I'm waiting on that, so I once again tried to pay for my quick node. So I sent 0.06 ether here. I'm going to refresh. Okay, renewal payment success. So this is how QuickNode is supposed to work. I tried to use QuickNode in another seminar. QuickNode is a really nice service. If you're building anything that needs a dedicated node, you can go to QuickNode, pay 0.06 ether, and you get it for 7 days. There's also different lengths of time you can get it. But we're going to use this. Now that this is up, we're going to connect to it with web3py actually, and we've been doing everything with web3.js so far, which is good for building web pages. But if you want to build sort of a lower level, well, let me put it this way: if you want to interact with a contract without building it as a web page, web3py is a really good option there. It's sort of, and I would say it's sort of in second place in terms of interacting with Ethereum smart contracts. Second place after web3.js. Interesting. That's too bad that doesn't work. We'll have to troubleshoot that later. So, okay. Now, let's see. I guess one thing I can do is I can get the link, and I'm just going to put this in the post. So if anyone's watching the YouTube archive of this, follow the video description of the post here. Let's see, because I'm going to put this in as a link. So look for that link. I'll probably have it labeled something else after the video, but you can go there and log, punch your clocks, whatever. You can see how this is sort of automatically online, automatically hosted. We don't need to worry about anything. It's just up there sort of forever. And it has, this contract, of course, has no suicide commands in it, so it'll actually exist forever. This will never go down. It's impossible to destroy as long as the Ropsten Ethereum network continues to chug along anyway. Okay, so we have our quick node here, so yeah, we're about halfway through the seminar now, and now we're going to move from the Solidity. So we usually try to do Solidity on Mondays, but our contract is so simple, there's really nothing more to do. So now I'm going to move into getting connected with web3py. Now, so what you want to do is you want to go to this page and then go down to Developer Tools. And this is, technically speaking, this is sensitive information. So the fact that I'm streaming this is sort of, some might call it insecure. However, this is just a node that's out there that I haven't put any ether on. However, if I was using this node to actually store ether, this could be sort of insecure. I don't think anyone could just connect right away and steal my ether, but it's not really, this node software that I'm going to connect to. It's interesting in the oh, whoops, I don't need that whole thing. Let's see here. Okay, I'm going to take this. So when I connect to this node on web3py, the way that this node software is designed, and you can choose, by the way, if you can modify your node. You can choose whether it's Geth or parity. I'm not going to mess with it right now. but you've probably heard of the Geth and Parity software. So that's what we're connecting to. We're literally connecting to a Parity client or a Geth client that you would run on your desktop if you wanted to. And the thing is that these both are programmed with the assumption that you're connecting to it from the same machine or over a trusted connection. They're not really built with the assumption that you're connecting via a service like QuickNode. So what that means is that the way to connect to it, the best way I found is this WebSockets one, and it has the token right in the URL here. So anyway, just be aware of that security thing. Don't put, if you're going to be streaming like I am and you have your token in your name, just make sure you remember that and you don't start putting money on your node that everyone has a token to. All right, so let's get a Python prompt up and go in. I might not have Web3. Let's see. Oh, good. Okay, I have Web3. Now, Web3 for Python. I'm going to go, let's see, web3py connect to node. Yes, indeed. That's what we want. And it should be this very first one. Now, one nice benefit is that since we're not using MetaMask, and remember, MetaMask is what was holding us back from using the newest version of Web3.js. And that was quite frustrating. We don't face a similar restriction in Python. In Python, it's really easy to stay up to date with the newest Web3. So that's super nice. And of course, it's quite easy to install, pip install Web3. And let's just, let's see. Nope. Where do I connect to? Oh, it's not going to tell me to connect because here, where does it say? Use the auto module to guess at common node connection options. Oh, here we go. So it tries to make it easy. This usually doesn't work. This section, this auto bit here, this line right here, unless you have a locally running node. So if you have a local running node, you can do it. If not, you'll have to go and click on this link here, choosing how to connect to your node. And here's where we'll use our quick node here. Examples. I want to see the one for WS WebSockets. That's the link we got. I guess it's just maybe I'll just read this here. Okay, so we're going to go, I'm going to call it W3, and this is going to be our provider, and this will be similar to the Web3 object in JavaScript, Web3.js. So I'm going to call it W3 just to avoid naming confusion with the library Web3. W3 equals Web3. Oh, actually, I need to do it like this. From Web3 import Web3 like that. More confusing names. Import. Okay, let's see what Sayron has said. My mic switched. What the hell? Sorry about that, guys. That's super annoying. Let me go to here. Properties. You know, my sound card is going out. The one that connects to my nice mic. Oh, and it still didn't work. What did I do there? Built in. That should work now. Okay, that's better. Yeah, that's annoying. Thanks for letting me know. Sorry, I was going on there for a little while on the bad mic. Did it happen again? It looks like it's... Is it working now? Oh, okay, great. So, okay, so Sayron now has MetaMask working with Pragma. So now if we go here, we'll be able to load the logs. Have you made a log yet, Sayron? Those doesn't look like it yet. So let me know when you've made a log and we'll just come look at that. I mean, it's not going to be too surprising, but it'll be cool to see that we're both using the same contract. Okay, so let's see, back to our Web3 stuff, our web3py stuff. So, and let me just, I'll take these links too and put this link in the blog post. So that's that'll be in there for you guys. Okay, and then Sayron has something to say. I did pending. Okay, cool. So we'll check back on that in a few minutes. I'll I'll try to keep an eye on the transactions. Let me know if you notice it got mined. I'll try to remember to check back. Okay, so now we have, of course, Web3 is the module here. Now capital W Web3 is specific. It's a class, and so now we can say W3. And I'm tempted to just say Web3. I just don't want to overwrite the module. So that's a bit weird, but okay, W3 equals Web3 dot, and now we're going to do WebSocket provider. And feel free to experiment with these. Of course, you have three types here: IPC provider, WebSocket, and HTTP. IPC provider is I think that's mostly used on a local machine. So if you have a node running that for some reason Python can't automatically connect to from this previous page you're looking at, you can use IPC to get there. You can also use WebSocket and HTTP for the local node too, but we're not connecting to a local node, we're connecting via WebSockets. Okay, so I still have in my clipboard what I got from my quick node page, that bit there. Now I'm going to copy that right in here, and I believe I just put it in quotes and do that, and that's, oh wait a minute, that that's not what I wanted. I need to copy that again. And you'll notice it doesn't give you an error here if you give the wrong URL. It doesn't test the URL upon instantiation. You sort of need to do that in your own way. And here's how I do it. Oh, I need to close the parentheses. Let's go back to this getting started page. I just see if I can get the block number, which I believe we can just do like this. No, w3.eth.block number. That might be it. No. Okay, what am I doing here? Oh, wait a minute. I skipped a line. Okay, my bad, guys. I'll have to make a note in the video. I did that wrong. Okay, I'm just going to redo this all. Let's see, I'm just going to quit Python, start it up again. Now this is Python 3, import Web3. From Web3 import capital W Web3. Now we need to make a provider. So I'm gonna call this the WS provider for WebSockets equals Web3 dot WebSocket provider, and then put our URL in there, close it, and now we can say W3 equals Web3 WS provider. And I think I usually do that on one line. You can sort of concatenate those lines. Concatenate, I guess. All right, now let's try this again. W3.block number, or it's .eth.block number. W3.eth.block number. No? Okay. Let's go back to this page. What is it that we do? Oh, this is, nope, that's not what I want. I wanted to go back here. Quick start. W3.eth.block number. So that should have worked, I guess, but it doesn't seem to be working. ETH module has no... Oh, I need to capitalize the N. Okay. Block number. Okay, so that's good. So that's how I usually test if I actually have a connection. I just try to call the block number. And if I get it, that means it must be connecting to the Ethereum blockchain. And with QuickNode, I know that they're usually synced, so I don't really need to check this, but if I wanted to, and especially if you're using your own node that maybe is still syncing, this block number is going to give you how far it's mined, not necessarily how far the network is. So I'm going to go to etherscan.io, etherscan, and look at the last block number. So the last block number is 318, and indeed that is, if I just do this, there we go. So now we're on 318. Now, something I just realized is that this is looking at the mainnet blockchain. And our contract is on Ropsten, and I'd like to get connected to the contract, so I either need to switch the network of the node. Well, let me slow down here. There's two things we could do here. We could change our node here that we're connecting to. We could have that connect to Ropsten, and in that way get to our contract, or we could just deploy the same contract on mainnet. either one is fine. But if we were, I don't know if we were to change the node, we would need to go to our quick node page here, and we would need to go to modify the node. You guys might have seen chain selector here, so we could change this to Ropsten. However, I don't want to do that. It would take a little. It takes like a minute or two to restart whenever you change any of this. As you can see, the button is called Rebuild Nodes. You really have to rebuild the whole thing. I believe it syncs very quickly based on some magic that QuickNode has. I don't know the details there, but it still takes like a minute or two just to rebuild the node. So rather than do that, I'm just going to go back to Remix, and we did make some changes anyway. So now I'm just going to compile it. We'll see. I'm going to change to mainnet and compile it and deploy. Now, unfortunately, that will mean, say, Ron will have to use mainnet. Say, Ron, if you don't have Ether, I'll just send you just a little bit from my wallet just so you can interact with it. So let me know if you don't. Just send you $1 or $2 or something like that. Okay, compile and run and deploy just like last time, and then do not ask me that ever again, please. I'm going to make the gas price a little higher. And I'll be interested to see how much it costs to deploy a contract that's so simple. So we'll see. Usually contract deployment is the most expensive operation on the contract. But it says max transaction fee is only going to be 50 cents, and 10 gig away is sort of high. So, and we'll see. And it could spend less than that if it uses less gas. So we'll watch this. Refresh. It'll find it here in a second. Okay, man. Yeah, just post your address. Yeah. Oh, my fucking mic. Okay. Sorry, guys, on the mic. Yeah, I'll send you a bit. Just give me the address. Post the address there, Sayron, and I'll send you $1 or $2. And I need to, I guess, change my mic again. That's so annoying. I need to like go in here and select that, and then go in again and select the other one. And it's just because my sound card is being a piece of shit. I need to fix it. Okay, so we've got mined. Let's see what Sayron is saying. Okay, I'm going to send him just a little bit of Ether right now, just so he's ready to interact with this contract as well. And now, Sayron, you can actually add this contract in the same way as we did the other one, just change to mainnet. And I guess you don't have the ABI, so I'll do that whole thing with Pragma again. First, I'm just going to send you. Now, I actually might, let's see, run out of Ether. So I'm just going to send you, let's see, 0.002. And that should be more than enough to make a log. I'm going to have to dig into my Coinbase account if I run out of Ether here. Okay, so this is now deployed. I'm going to click on this contract, and again, same thing as last time, but now we're on mainnet. And so this is costing me actual money. I'm going to go to Pragma, and now if I go to contracts, the list will have changed because I'm on mainnet now. You can see I've deployed a lot more on mainnet. Mostly these are experimental, but I'm going to add existing contract just like last time, put in the address just like last time, go get the ABI just like last time. File, details, and ABIs right there. Notice only 2 entries, and that reflects the fact that there's only 2 things here. There's an event and a function. It's kind of interesting. And then put this here, and then put the name. Again, this name can be anything we want. We're just making it the same name as our contract. We don't need to do that. Okay. Interact. Now, here we go. I'm going to make it shareable. Confirm. Now I'm going to copy this link, and once again, hand it off to Sayron here. So now we should both be able to interact on this contract. But what I really want to do before the seminar is over is connect to this with web3py. Now, okay, just real quick, this W3 object is extremely similar to the Web3JS Web3 object. So you can build contracts in a very similar way, and you can You can look at events. I mean, it's all very similar. There are some differences, but you'll notice a lot of similarities. So if you can build things in web3.js, you can build things in web3py. Of course, you'll need the documentation up to see what those small differences are. But so let's see what we can do here. So now we have this on mainnet and our contract is on mainnet. I guess I want to get the ABI and the address as variables in Python. I'm not going to be writing any scripts here. I'm just going to be using the prompt. We only have 18 minutes left, so I'm just going to demonstrate how we use web3py in general to connect to contracts. So let's see. I'm just going to say ABI equals, and I think it's might be still in my clipboard. However, I'm just going to paste in the, nope, okay, that's not there. So let's go get the ABI again. Excuse me. Okay, details. ABI. Does this get, so yeah, it gets pasted in a weird way. Also, this is a JSON. So what I'm going to do, because Python will fail with this because it's not really in Python. So I'm going to put these 3 quotes around it. Now, if you have written in Python before, you know that it just means it's a multi-line string. So that's why I'm using this text editor to just throw those around there. Now I can go to Python and I should really say ABI string equals, and then I'll paste and enter. Okay. Now I think I have to import JSON. Is that right? Yeah. And then I can say ABI equals JSON.load S for load string, and then ABI string. Okay, now ABI, oops. So there is our ABI. And just remember, you have to keep in mind that what you first get is a JSON encoding. So you need to do that small translation from JSON into Python, and an easy way is to just make it a multi-line string like that, and then use the JSON.load. Okay, so now we have the ABI. Now we just need the address. So let's get that. And that will be, let's see, right here. And in quotes. Okay, now let's go. I use web3py often, so I'm going to have to go look at, let's see, web3py contracts. Yes, okay, we don't, oh, this is compiling. We don't need to compile. Let's see. Okay, this is the line that we want. No, this is a deployment line. Here we go. Create the contract instance with a newly deployed address. That's what we want. So, I'm going to say punch clock equals w3 .eth.contract. Again, this is extremely similar to the web3.js function we use. Address equals address. ABI equals ABI. And I think that's it. Okay. Now, again, this is another line that will not give you an error if you've messed something up. Well, it'll give you an error for some things. If this address was malformed, I think it would have given me an error. But if the ABI was wrong, or if there's no contract at the address, it would not have given me an error. So just be careful. You just know you might not find out it doesn't work until you actually try to call one of the functions. Which, let's do that now. So let's see. We want to we can do 2 things. We can either try to punch with Python, or we can get the event. I'm going to get the event first because this node that we're operating through actually has no ether, so it won't be able to pay for gas until I send it ether. And it's not even that simple. I actually have to send it ether, then unlock a personal account. That gets a little hairy with web3py, so I'll leave that for tomorrow. For today, let's just see if we can look at the events. So before I do that, I want to make sure there are events. I don't think I actually used this yet. Let's go to logging. Maybe Seiron has done something on this. Just waiting, loading on mainnet. Loading the events. Okay, looks like there's no events, so I'm going to go ahead and do a punch. And Seiron, if you could do the same thing, just so we have a little bit of variety in the events. But I'm going to submit there. Okay, now while we're waiting for that, oh, I sent it to that address. You should see it now. Have you checked again? Maybe it's still mining on mine. Let me see. Oh, it is still mining. Okay, I'll click this, retry with a higher fee. And, oh yeah, okay, MetaMask gave it 1 gig away. That's stupid. Okay, you should see that within a minute there, Sayron. And I bet this contract also gave it a small fee, small gas price. Yep, it sure did. All right, so those are both now going to be resubmitted with higher gas fees. They should go quicker. So you should see that in your account, hopefully soon, Sayron. Okay, let's see, back to Python. While we're waiting for those to mine, we have our contract variable. Now let's scan for an event. Let's see how to do that. Contracts, and I believe it's down at the end of this page. Properties, methods, event log object. Yes, this is what we want. So, let's just call it a log filter for now. Log filter, I'm just going to call it filter. Filter equals the contract, so punch clock, dot event, event filter. Then we give it the name, which I think was punch event. Is that right? Let's just double check. Let's see if my log has showed up yet in this. But I believe that's what the name is, so we'll leave it in there for now. I guess I can close some of these pages. Okay. We don't need a filter. We can add that in later, but that's if we wanted to somehow, well, as you can see, we can limit, for example, our agent argument in our code here. We could limit it to certain agents, which will be useful later when we build up this interface. But for now, I'm just going to leave it blank there. And I believe it's web3py that if you just omit this dictionary, it can cause issues. So I pass in an empty dictionary like that if I don't want to have any extra filters. Okay, that looked good. Again, this won't really fail. It'll fail if we've done something wrong. It'll fail in this next line. Okay, so filter dot get new entries, and I believe. Well, let's just see what happens. Okay, let's try filter dot get all entries. Uh-oh, that's no good. Hopefully that just means our stuff isn't mined yet. Okay, so now that is a problem. So you can see that my transactions went through, well, these two say dropped. That's big, whoops, dang it, didn't mean to do that. These two transactions say dropped. That's just because I increased the fee. So these are the same two transactions. So Sayron should have the ether now. Should be able to make the event. But what is sort of disconcerting, or what's going to be a hassle we'll have to figure out, is that I bet that if I refresh this, this will show the events on the contract. They should be out there because that punch command I made went through on the contract without failing, I believe. I mean, let's just go and I guess we can look at the actual Etherscan transaction. Let's go look at this one. This was my punch action, and you can see event logs 1. So there should be one event log. However, these two lines don't seem to be getting anything. So once again, we're running into events on Web3 not really working very well. We only have 9 minutes left. I don't want to break my back trying to fix this in this seminar, but I've at least shown you guys how to sort of create in web3py the contract. You can see it's extremely similar to web3.js. I suspect that this issue where I can't see these events has nothing to do with the Web3 code. It has to do with our quick node here. And I remember that last time let's see, where'd my quick node Where'd my quick node go? Quick node. That must be it. I don't want to renew though. Dang it! I got to go into my email and grab that link if I want. I guess I could look at the history. Where's my quick node? There we go. But I don't want to be there. Dang it. Okay, let's just take off this modify. Okay, so I suspect, oh, node logs. I wonder, no, that's not what we want. So last time I built this quick node, or I used this service, I had to actually contact their Slack and ask them to rebuild the node with certain flags. So I'll probably have to do that again. And that is probably because these quick nodes, typically a node, as I was saying earlier, a node can sort of, when you start the node, you can tell it how you want it to store logs, whether you want it to store any event logs at all. And I suspect that these guys just default to not storing any logs, because that increases the data footprint of the blockchain like an incredible amount. I mean, I don't know the numbers exactly, but it goes from like 50 gigs to like 500 gigs. It's like an order of magnitude. I think those numbers are wrong, but it gets way huger if your node stores all logs. So probably what happened is that this node is starting and it doesn't store logs, and so we're trying to get the logs. It says it doesn't have any, but that's just because it didn't retain the records, even though they are on the blockchain. So that is something that I will contact them and try to fix up. If you're running your own local node, this would be something that you would have to change on the command line. Maybe you would shut it down and start it up with another flag. If you had Parity installed, I believe Parity has a UI that you could go and change it on, although I'm not positive on that. But anyway, yeah, so there's that. So moving forward on this web3py, which we will start on tomorrow, that'll be the first thing. Hopefully I'll have all this sorted out by then. I'm going to send them a message sort of shortly after this this video, try to get that sorted out. And then the other thing we'll have to get past is getting Ether onto the node and using that Ether, or we can actually create our own private key and use that to initialize commands. So we'll be doing one of those two. I'm leaning towards the second of those options, actually using our own private key, because then we don't have to store Ether on the node, which that we're giving out the token to. So yeah, that's what we'll get into tomorrow. Is we'll just we will hopefully I'll have pushed this problem forward a little bit on my own, and then we'll push a little bit further and get sort of a low-level command line sort of interface built on web3py to allow someone to at least look at the punch events and sort of do some basic tallying, like maybe for any given agent, you can look at when they clock in and clock out and like tally the total, for example, and maybe even get to the point where you can actually clock in and out on Python. So that's what we are going to tackle tomorrow. Yeah, I guess I'll end it there. There's 4 minutes left, but I think we're at a good stopping point now. Yeah, that's it. I will see you guys next time. Thanks for tuning in.